look at activity 3.9. So number 1, okay, the instruction number 1, set up the apparatus. Okay, so here we go. We have Centripetal Force kit, a plastic tube, okay, the red one, the one that the man is holding, and then the rubber stopper, slotted weight holder, 3 50-gram slotted weights, crocodile clip, thick string, and ruler. Okay, but here we use washers, okay, and each washer has a mass of 10 grams. Okay, so our what we have in simulations a little bit different from the one in the textbook. Okay, so instruction number 1, set up the apparatus for circular motion of radius r equals to 50 centimeters. So let's change the length. Okay, so that's more than 50. Okay, so that's 60. Okay, so write that down. The total mass of the slotted weight is 100 grams. So do we have 100 grams? So here is 7 washers. We just want it to be 100 grams. Okay, and then hold the plastic tube in your right hand and the slotted weights in your left hand. Rotate the rubber stopper at a constant speed above your head as shown. Make sure that the crocodile clip stays at a distance of about 1 cm from the lower end of the plastic tube. Okay, so this one. Okay, release the slotted weight and continue rotating the rubber stopper. Observe the speed of motion. Okay, so that is what we will do. Observe the speed of motion of the rubber stopper. Okay, so let's start. Okay, so that's is the speed of rotation. Okay, so next we are going to continue. We are going to repeat steps 1 until 3 with total mass of 200, about 300. About 200. Okay, so okay, let's start now. Observe the speed of rotation. Now, see any difference from previous rotation and this one? Okay, now compare the speed of motion of the rubber stopper with the speed of motion in step 3. Okay, right, so let's pause that. So we're going to do the third trial. Repeat step 4. When the rubber stopper is rotating, pull the lower end of the string downwards so that the rubber stopper rotates with decreasing radius. So we are decreasing the radius. Okay, if you do this in the lab, okay, you need to feel how the tension in the string acting on your left hand changes. Okay, so the discussion question: when the rubber stopper makes a circular motion, the stretched string exerts a force on the rubber stopper. So what is the direction of the force? Okay, so the direction of the force is towards the center. What is the relationship between the speed of the rubber stopper and the centripetal force? These are the questions just now. Okay. When the rubber stopper makes circular motion, the stretched string exerts a force. Okay, the force on the rubber stopper. So that is actually the centripetal force. So the centripetal force is actually the tension. Another name for the force is the tension of spring. So if you are doing this, you will feel a pull. And for a body in circular motion, okay, like this, a force acts on the body in a direction towards the center of the circle. Okay, and it should be like this. Alright, so the tension, okay, so this is the circular motion. Okay, and then actually here, so this is the rope. Okay, so the centripetal force is, I think this one, on the rope. Okay, and then we say that the centripetal force, okay, first it depends on the mass of the body. Okay, and then we know also the force, centripetal force also depends on the linear speed. Okay. Okay, where is the linear speed? So if this is the object, so the linear speed is towards the tangent of the circle motion. So if it was here, you know, the direction of linear speed is this way. If it is here, so that's the tension. Okay, that is the linear force. Okay. Right. And not only that. Now, if you look at the simulation, what happened if just now we have a longer radius. So what if we reduce the radius? Okay, reduce the radius. Okay, compare it just now with this one and the previous one. So this one, the linear speed or the speed of rotation is slightly higher. Okay? So we see that force, centripetal force, is inversely proportional to the radius. So if the radius is smaller, the centripetal force is higher. Okay, right. So this is an activity in the textbook. So you should do this when we are at school. Okay. 3.9 to understand centripetal force using centripetal force kit. So this is simulation of centripetal force.